Okay, we're going to go over the notes today for Unit 8, Lesson 9, modeling with a piecewise linear function. Please pause the video and copy down the learning goal in your notes page. The learning goal for today is I can calculate and interpret rates of change in context. So again, pause and copy that down, and then we'll move on to the rest of the notes. Okay, so in our context for today, we're going to be talking about DeAndre, who is giving their dog a bath in a bathtub. This graph shows the volume of water in the tub in gallons as a function of time in minutes. So we know that the two things that we're comparing is our amount or volume of water in the tub measured in gallons, and then our time in minutes. So we are going to start by thinking about why do we think this function is called a piecewise linear function? And the reason why this is a piecewise linear function is because it's made with multiple pieces. So when we look at our graph, we see that we have three sections or three lines to our graph. So the reason why it's a piecewise function is because it is made of three sections of straight lines. If we have one line going up, then that is not a piecewise. If we have a line that kind of curves, then that's not piecewise. In order for it to be a piecewise function, it has to be straight sections of lines. So please copy this answer in our first box and note that I'm going to say that it is straight lines because that's going to be extremely important in our notes. Okay, so next, so we have the three chunks of our line. If we're looking at our graph and we're looking at those three chunks of our line, let's think about what those chunks mean based on our context. We know our context is talking about DeAndre, who is giving his dog a bath. We know that we're talking about minutes and gallons. And if we look down at the bottom here underneath, we know that X is representing our time in minutes and Y is representing our time the amount of water in the bath in gallons. So I'm just going to label this as minutes and over here as gallons. So when we look at that first part, we see that we're starting at 0, 0. So this is a proportional start that we're starting at that origin. No time has gone by. There's no water in the tub. As time starts to go by, we have a 3 minute and then 6 minutes going by. We see that the water in the tub is increasing up to 24 gallons. So this first section of our line is representing when DeAndre is filling the tub. He has to get the water in the tub in order to give his dog a bath. Then we see from 6 minutes to 18 minutes, so I'm going to draw these points, that the water level didn't change. It stayed at 24 gallons. But we had a time of 12 minutes go by. This section would be where he's washing his dog, right? He's not adding any water. He's just staying with the same amount of water in the tub. So therefore, the dog is in the tub getting washed and our water level is not changing. Then from 18 minutes to 30 minutes, we have this decrease of water where our water goes from 24 gallons back down to 0 gallons. That would be the section where he's draining the tub. So please make sure that your graph is labeled with the different sections and what they mean based on our context. So our first question is asking for the rate that the water filled up. So this is going to be when in our first section, right? That's going to represent that first section when he's filling the tub. So in order, oops, helps if I spell section right. In order for us to find that rate, we're going to remember and go back to slope, which is our change in y over our change in x. Because our change in y over our change in x is going to represent our unit rate, or how fast the water is filling the tub. In order to do that, I need to find points. So I'm going to start at the 0, 0, and I'm going to read my points going up, going left. So I'm going to follow my line up, and I'm going to look for those perfect points. I have 3 perfect points on my line. So now I'm going to make my stair step. I'm going to think about my, let me change that color. I'm going to think about going up and then over, up and then over. So when I'm going up, that's representing my change in y, right? So my y is representing any time that I'm moving up in this. So if I'm looking at my difference of going up, I'm going from 0 to 12 and then 12 to 24. So I can think in terms of that as being 12 minus 0, or I could do 24 minus 12. But I would need to do the difference between my points on my y-axis. For my x, for my time, that's going across. So then I need to look and see what my unit is. I can't just think, oh, I'm going over 1 box, just like I couldn't say I was going up 4 boxes. I have to look to see how much I'm going over. And I'm going over from 0 to 3 and then 3 to 6. So that means I can do my 3 minus 0, or I could do 6 minus 3. All of those would work. Oop, let me put that in red. Now, when I do my subtraction, 12 minus 0 is 12. 3 minus 0 is 3. And then I want to simplify my fraction. So in this case, I can divide top by bottom, and I can do 12 divided by 3, which equals 4. So my answer here is 4. But if we're thinking about what does that 4 mean based on our context, it means that my tub is filling 4 gallons per 1 minute. Okay, so our unit rate is always per 1. In this case, it's per 1 minute. So the tub fills up 4 gallons every 1 minute that passes that DeAndre is filling it. The next section is talking about when the tub is draining. So this is going to be our last section, right? We already kind of looked at our graph and saw the different parts. So we know that the tub is draining at the very end. We're going to use the same thing that we did before, where we're going to do our y over x to get that unit rate or the slope, because they mean the same thing. So I'm going to set it up the same as I did before. We're going to color code with our colors for our y and our x. And we're going to look to see where my perfect points are. So again, starting at 18:24, when DeAndre is done washing the dog, I'm going to follow my point left to right. So now I'm going down with my line, and I'm going to draw my perfect points. So as I go down, I keep finding my perfect points. For draining, I have a lot more perfect points than I did with filling. In this case, I have 5 different perfect points. So now I can make my stair steps going down and start to look at what is happening, what's changing, right? What's my change in y over my change in x? So as I'm going down 2 boxes every time. but I need to be paying careful attention to what is happening with those boxes. So if I go to this very last section down here, I can see that I'm going from 6 to 0. So then I'm going to put 6 minus 0. It doesn't matter which section. If you start at the top, you have a 24 minus 18, or you could do 18 minus 12. You could do 12 minus 6 or 6 minus 0. As long as you're going from perfect point to next perfect point, it will always work out, because any of those have a difference of 6, because 6 minus 0 equals 6. Then when I look for my change in y that's going across, I again have that one box. It's the same as what I had when I filled my tub, or when DeAndre filled the tub. So it's going to be similar to what I had there, only I do have different numbers. I'm not at the 0. So if I look, I'm going from 18 to 21, 21 to 24, 24 to 27, and then 27 to 30. So since I used that last chunk for my 6 minus 0, I'm going to use the last chunk and do 30 minus 27. So I'm going to use this part here where I'm going from here to here. So 30 minus 27 equals 3. And then I can simplify like I did up above. So I know that I can do 6 divided by 3, which equals 2. It's going down and we're draining, so it's a negative 2. That's going to be my rate. And what that rate means is that it's draining 2 gallons per 1 minute. Okay, but we know that it's a negative for 2 reasons. 1, if it's draining, then that means the water is decreasing. And 2, when I read my line left to right, it's going downhill. So the last part of our questions that we're going to answer here is select one linear piece of this function and then write an equation for that piece of the using the form of y equals mx plus b. So for this, I'm going to use that first section. So I'm going to go up to this very first section that we did. And I'm going to take my information from here and I'm going to write it in my equation of y equals mx plus b. So I'm going to start by putting my formula, or my equation, y equals blank x plus blank. And I'm going to make sense of what that equation means. We should remember that our first part next to the x is our rate. In this case, it's our rate of filling the tub. So in this case, it's that positive 4. It's what we calculated in that first part. So in this case, it's the rate of filling tub. Oops, as I say tube. Okay. And then the second part is going to represent my starting amount. Okay, so this is how much water was in the tub to begin with. So in this case, that section of line started at the origin, so it's going to be a starting amount of 0. So my equation for that first section is going to be y equals 4x plus 0. I could also rewrite that equation if I wanted to as just y equals 4x. I can leave off the section of plus 0 because it represents the same thing. Now, if I wanted to do the second part, so let's now write this equation and we're going to put it underneath here. I can set up my layout, and I know that it's going to be y equals space x plus space. So in this case, I'm going to use my information from when the tub drained. So here I have my rate. That's going to go in front, and now this is my draining tub. So in the second part, we found out that it drained at a -2 or 2 gallons per minute. So I want my slope or my rate to be -2. And then my starting amount, if I look at where that line starts, that line is starting up here, and that's going to start at 24 gallons. So my starting amount is 24 because I want to know how many gallons it started with. Remember, that is your y-intercept. So I need to be looking at my y-axis. Okay. So my equation for that part is going to be, if I was writing the equation for the draining, it would be y equals -2x plus 24. So you can see the difference between the two equations depending on what part of our line or what part of our piecewise function we're comparing. Please make sure that your notes are complete and that you have all work showing how we found those rates, so that you can use that to help you moving forward. And then please take a picture and put it into the class Kick so that I can see that you have your notes completed. Thank you.